Morning, Connor. How are you, Connor?
Doing well, doing well.
Good. I'm glad you stopped by. We're going to start. By the way, let me ask you, well, let me introduce the class to the whole class. And we are recording. Then I'm going to start with if you have any questions or not. Okay. The plan, of course, it's we have one student here. So, of course, I'll talk to him as well. The plan is, guys, let me see. I am recording. I want to double check. Yes. The plan is, guys, start three-dimensional geometry. I'm going to go over a few things that we have done so that you understand where we are. We have done area perimeter 2. We didn't do all the problems. I don't think I'll do all of them. We stopped here. And I will remember it. You don't have to panic. I think we stopped at number 14. You're not responsible for 15. So 15 is out of the picture. Now, the plan is to do three-dimensional geometry. It's a little hard. And people generally, when I teach it face-to-face, people do struggle a little bit. The good news is that the notes are already here. Okay, we're going to get to surface area of cylinder and cone later, certainly not today. The idea today is to work on this definition packet. It's in the notes folder. Okay, I'm going to share it, but I'm going to access it from a different source. And then we will have times to record, I would like to believe, some problems. And what kind of problems are we going to do? We're going to go to the problem sets. Notes will have the lecture notes. Definitions is not a long lecture. We are not going to do a long lecture. Volume and surface area 1 is what we are going to work on. It'll take us a couple of days, maybe 3 sessions to wrap up. And then we have one more packet. And if we do 2 more packets, I'll consider it a successful semester and we'll move on. So that's the plan, okay? Tentative plan. So let's see. Interestingly enough, yeah, I am sharing. So Connor, what can I do for you? Let's start with you.
Nothing. I was just coming on just to.
Oh, you're just attending. Sounds good. Good.
I won't be here long, but I just wanted to check in.
Okay, that's fine. So I'm going to go ahead and I'm going to, if you don't understand something, feel free to ask. That's good that we have somebody who can keep me, you'll keep me straight if I mess up. Okay, guys. So here are the notes, just 2 very basic definitions, okay? And I'm going to use a new software because it's easier to show some of those 3-dimensional objects. And when we do it, you're going to see we are recording, all those things. Now I'm just finding the definition, which I already shared with you. It's in your notes folder, okay? And it'll seem like a lot. It's not a lot. I'll tell you what I mean, okay? Okay. All right, so the first thing we will do is a cube. We are going to call it a unit cube. What's a unit cube? A unit cube is a cube. What's a cube? Well, a cube, the best example of a cube that we have, I think, is a die. Okay, it has 6 faces, and that's important to know, guys. 6 faces. Okay, 1, 2, 3, 4, 5, 6. How many vertices does it have? And we're going to use this over and over again. It has 8 vertices. 1, 2, 3, 4. I'm going to say 4 on the ceiling and 4 on the floor. It only has 8 vertices, and it's going to come in handy. Any cube has 8 vertices.
Vertices mean that when they connect, is that what you're saying?
Vertices are corners. Okay, vertices are corners where the edges connect. Does that make sense?
Yes.
Okay. And what are edges? Edges are places where edges are edges. It's the English word, right? So I'm going to draw your edge, the first one. This is an edge. Okay, so I'm going to erase some of this that are not relevant anymore. I'm going to count the edges, and it's going to come in very handy a little later. Maybe not today, but in future, near future. Where are the edges? How many of them are there? Well, there are 4 on the floor, ceiling, sorry. 4 on the floor. I know I can only see 2, but they're there in the back. And my drawing is not perfect and it doesn't matter. And I say there are 4 between the walls. 1, 2, 3, and 4. I know my drawing is terrible, but you get the point. Again, a cube has 6 faces. It's very easy to see. 8 corners. We're going to use the word vertices, and I can write a little better. And 12, actually, let's erase it. Let's do a nice job. 6 faces, 8 vertices. Vertices are simply corners where the edges meet, or 3 faces meet in this case, and 12 edges. It's something you want to really, really remember. And if you forget, it's quite likely you're sitting inside a room and the room is like a box, or you have some box floating around next to you, and you can look at it and you can determine 6 faces. Nobody forgets. 8 corners, 8 vertices. We're going to use the word vertices, and 12 edges. Okay, so let's set that aside right now. We're not going to use it today, but we're going to probably use it. Well, we may use it today. A unit cube is a cube. We kind of analyzed a cube. What is a cube? What it looks like, and what are some of its properties. If it's a unit cube, each edge is 1 unit. You could have 1 mile. You could have, if you're finding the volume of the earth, you're going to use 1 mile. If you're finding the volume of the room, you're going to use 1 foot. Will be your unit. If you're using volume of a little shoebox, you might use 1 inch, and people use 1 centimeter. So your unit cube is 1 unit on each edge, and that has 6 faces. And if it's a unit cube, this square is a unit square by default. If this is 1 unit, each face is a square, and that's going to be a unit square. And we talked about unit squares, and we talked about area. All those things come back again. Okay, so a unit cube is a cube that's 1 unit on each edge. Okay, fine. Now we're not that interested in unit cubes. We're interested in volume and surface area. And here's the formal definition. I'm going to read it, but you really want to understand it. Let me see if I can view it a little differently. Okay, that's better. So what's a volume, guys? Volume is the total number of unit cubes it takes to fill a 3-dimensional object. 3-dimensional objects are objects that we can play with. Your calculator is a 3-dimensional object. The mouse is a 3-dimensional object. A nice shoebox is a 3-dimensional object. Things you can lift and play with. So this is a 3-dimensional object. And let's say this is a cube, and I'm going to call it a unit cube. Each piece is a unit cube, 1 inch, 1 foot. I don't care. I'm just going to call it a unit cube. Now I want to find the volume of this box. Now, the catch is you cannot see all the cubes. You have to assume there are cubes, otherwise the structure will collapse. So we make some assumptions. So I'm going to carefully count how many cubes I have, and we're going to learn how to count the cubes in different ways. Okay, I'm going to show you how to count this cube in 2 different ways. Okay, and then we're going to do many more. So the first basic one is I'm going to go by layer. This layer, the bottom layer, has 1, 2, 3, 4, 5, 6, and there's 6 in the back. I'm going to say the bottom layer has 12. Then the layer above is very easy to see, has 2 and 2, 4. And the layer above also has 4 cubes. What's the total? Total is 20. So what's the volume of this solid? I'm going to call it a car-like solid. It's not a fancy word. It's called, the volume of this solid is 20 unit cubed. Done. Pretty easy. That's one way to count it. You know, bottom layer, top layer, middle layer, and so on and so forth. Does that make any sense, Connor?
Yes, it's kind of the same stuff we did in 3190.
Exactly. It's the same definition. Exactly. Yeah, I know. I know most of you had me for 3190. So these are the same notes. Let's try one more. I can say the front and back. I can see the front. The front, how many cubes are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The front layer is 10. Clearly the back layer, I'm not going to count. It has to be the same. And the answer is still 20. So you have to learn your way of counting cubes. In this class, a couple of things to understand. You have to put the units, and on the exam, you can say unit, cubes, or you can say to the power 3 is hard to enter on your exam. The catch is you have to learn how to count, and you have to count it correctly and not mess up. That's why it's nice to know how to do it in 2 ways. And if you do it in 2 ways, you're getting the same answer. You're in good shape, probably. Any question, Connor? So here is the answer. We got the same answer. What's surface area? The good news is surface area is nothing too different from area. Okay, when we have surface area, we are probably talking about a 3-dimensional object, and we are talking about the area of its surface. And if you recall, area is that how many unit squares it takes to cover something. Surface area is how many unit squares it takes to cover the surface. And the catch again is how do we count carefully so that we don't mess up? I'm going to count it very carefully. So, okay. So I'm going to find the surface area of this solid. And as we have mentioned, guys, well, let me do something here, if you don't mind. Okay, now it says 56. You can see the answer, but we're going to do it in a little more detail. Make it a little bigger. So I am being told, let's say, that these purple cubes are unit cubes. How many squares are on the surface? I have to include the bottom, I have to include the back, I have to include the sides, some of the sides that should be visible if I move around or hold the object in front of me and rotate it like this. Other than that, I just have to be careful. So let's try it. So I'm going to count the front one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I'm going to write right here 10. And there's 10 in the back. I'm not going to waste my time counting it. How many are in the bottom? I can't see, but it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to check it twice. This is the bottom. Bottom has to be 12. I'm going to check it again. 6 times 2, 12. That sounds about right. Now, I am going to use a different color, purple. I want to count all these cubes. This, 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 this. And there are 2 that I can't see. And then this, and there's this. How do I count it, guys? The best way to do it, I'm going to put a little dot here. Everybody will have to develop their own way of counting. 1, 2, let's do it nicely with a star. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't forget that. There are 12 that I haven't accounted for, and there will be 12. Its cousin or brother. So there will be 24. I think, if I'm not mistaken, I've accounted for all the squares that are exposed. What's exposed? If you want to paint it, you can paint it. It will change its color. So what's the surface area? Hopefully I get 56, 24, the pink, plus 10, plus 10, plus 12. And I think I get 56, 20, 30, 40, 56. So I'm in good shape. That's my surface area. So on the exam, you're going to write unit squared. You can write it like this. That's perfectly legitimate. Saves you a little bit of time, but you have to put the square. You want to put the unit. I don't take off points if people don't put the units, but it's always a good habit to put the units. I'm going to pause here a little bit to see if we have any questions from anyone. Just a little bit. It gives me a little bit of breathing time. Okay, I'm going to clear everything. I think we are recording. I'm pretty sure. Okay, this is a term we will encounter soon. We're gonna discuss it. What's a uniform cross section, guys? A uniform cross section means if you slice something like you're seeing in this picture and this picture, you're going to get the same shape. In this case, you're going to get a square. In this case, if you take a Pringles container and you could slice it parallel to the lid, you're going to get the same circle going down. And that same circle, if it doesn't change in size, then we say the solid has a uniform cross section. If you take a stick of butter, this thing looks like a stick of butter, and slice it, you're going to get this kind of a cross section, a square, probably an inch or 2 inch square. I don't know how big they are. And that's called a uniform cross section. So we're going to conclude that a stick of butter has a uniform cross section. The Pringles container has a uniform cross section, but there are things that don't have a uniform cross section. This one does. A cone doesn't. I don't have a nice picture, but I'm going to try to draw it, guys. A cone doesn't have a uniform cross section. You can slice it like this, you're going to get a small circle. You can slice it like this, you're going to get a bigger circle. As you go down, your circle slices will get increasingly bigger and bigger. So there are things that do not have a uniform cross section. There are solids that do have a uniform cross section, and that's what we mean by it. All right. So we discussed volume of prism and surface area. I'm going to take a solid and work on it. So why did I say this? This will seem a little daunting. This document that I'm working on is available in the notes folder. However, this has a bunch of problems and you want to try them, and the answers are right here. In class, I do 2 or 3 examples. I'll do a couple of examples today from here, okay? So these are the solids. The answers are right in the bottom. You probably don't want to see it first. That will tarnish your thinking skills. I'm going to do a couple of difficult problems, and it will help you see how you can find the volume and surface area. I'm not going to do all of them. I'm going to do a few of them, and you're going to practice the rest. And then we're going to go on and do some problems from our packet. Okay, that's the plan. Let me do this one.
A lot of these solids we looked at last semester. I've noticed.
You did. I know. And that's okay. That's okay. The problem said that, let me explain this to you, Connor. You're raising an important point. Look, the definition of the basic definitions don't change, right? So I'm still defining the terms and defining some of the tricks, but then the good news is the problem set that I assigned and we will work on will not be the same. Does that make sense?
Yes, sir.
So we'll do new problems, but yeah, if it's a review, enjoy it. Now, if you want to participate and do some work, we are recording. I'll be happy to let you talk. I don't see a problem. If you want to share something that I would like to do that, I'll be happy to let you do it. Okay. Just let me know. And I am very aware of it. These are the basic definitions. Whenever I teach geometry, I use this same notes. All right. And I'm glad we have done it and you remember it. That's a good thing. Okay, guys, so how do we count the number of cubes? Let me take it to well, let me get up. These are the same problems, okay? I have a different document. It's a little easier for me to, I copied these same pictures. They're there, okay? I'm going to do some of them. I'm going to do 2 of them. And I think Connor is right. I'm going to do 2 of them. You're going to do the rest of them. I don't think anybody will have too much problem. These problems mostly came from American middle school texts. I don't see you guys having trouble with those. They're not that difficult, but I still want to go over a couple of them. Just 2. I'll do 2. For some reason, it won't let me. open my file. Okay, I'll do this. Actually, I'll do 2 and 4. Okay, remember guys, we talked about edges and all those things, and that's actually that knowledge that a cube has 6 faces, 8 vertices, 12 edges will come in handy. So they're saying these cubes are unit cubes, and you have to find the volume and the surface area. Okay, I'm going to do it like this, guys. There are going to be 12 edges. There are going to be 12 cubes like this, 12 groups, 4 sets on top. Hopefully you can see my pencil. 4 sets in the bottom, 4 between the walls. Remember, edges of a large cube. So I'm trying to count the cubes. It's hard to count, hard to keep track. So I'm going to say my volume will be clearly 12 times 3. Plus, remember I said we will have 8 vertices? These are the vertices. 1, 1, 2, 3, 4, 5, 6, 7, 8. There will be 8 corner cubes. Hence, I will write plus 8. Okay. Now, that accounts for everything. Well, let me think. Yeah, that accounts for everything. I have nothing in the middle. So my answer will be 12 times 2. Sorry, 12 times 3 is 36 plus 8. And that's 44, if I'm not mistaken. I'm going to write UC unit cubes. Done. Now I will go check my answer, but let me do my volume surface area as well. Again, is this the only way you can count the cubes? No. You have to find your own systematic way of counting the cube without messing it up. So that's the volume, which is 44. Let's see if we have any questions from anyone. All right, guys, let's find the surface area. I'm going to get rid of all the writing and I'm going to go check my volume. I hope I didn't mess up. 44 sounds good, which was number 2. Okay, now let's find the surface area. I'm going to actually, I like writing on my Word document. So guys, to find the surface area, I'm going to decide that all the corner cubes have 3 exposed squares, and there are 8 of them. Okay, I just counted them 8 for my previous problem. That hasn't changed. I have 8 corner cubes, and each of them has 3 squares exposed. So I'm going to write 8 times 3. Where's 8 coming from? Well, I'm going to make it a little bigger. 8 is 8 corner cubes. Now, and you have to visualize it a little bit, and it's not the easiest thing to do. So I counted all the squares that are on the corner cubes. What about the edge cubes? By edge cubes, I mean this. I have 3 of them here, and there are 12 such rods. That's 36, but each cube shows 4 faces. I'll convince you as follows. 1 here, 1 here, 1 in the bottom, 1 in the back. Each cube has 4 exposed faces, and there are 36 such cubes. Where is 36 coming from, guys? 3 times 12. Okay, no problem. All right, go. That's fine. Thank you for stopping by, Connor. See you next time. So I am going to go ahead. And I'm going to write 36 times 4. And that turns out to be 8 times 3 is 24. 36 times 4 is 144. And 144 plus 24 is 168. And I vaguely remember unit squares. I know my answer is correct. I vaguely remember seeing it, but for the record, I'm going to show you again. So number 2 is 168 units squared. So that's correct. Okay. Now, we have I'm not going to actually work on the packet today. It's the introductory definition. I'm going to show you a few more problems here. Okay. They're a little difficult, but it's nice to have them recorded. It'll refresh your memory. So we did this one. And how about the next one that I wanted to do? Number 4. Let me save it. I'm sorry, guys. I have to fix something, okay? So give me 1 second. Okay. And sorry about the interruption. I am going to go back and work on a couple of other problems. All right. As promised, I will do actually all of them. Okay. I'm going to now do the first one. I initially said I'll do 2 of them, but I think it's a good idea to do all of them. And that way, when we do something a little more difficult, you will be able to follow. So the green cubes are unit cubes. And I am going to count the cubes to find the volume. So let's write down that that's what we're working on, volume. And we will also work on surface area. Let's list them down here. So what's the volume, guys? How do I count the cubes? Well, it's not too difficult. Go by layer and layer by layer. This is 7. This is 6. And this is 3. And if you count them, add them all up. Again, 7 is 1, 2, 3, 4, 5, 6, 7. You have to kind of visualize it. It's not so easy because you cannot see them. And the top layer is 6, 3 and 3, 6. And the all the way top, all the way to the top, the very top layer is 3. When you add them up, you get 16. And you always want to put the units. Now, let me make this picture a little bigger. So that I can write on it. So I haven't found the surface area. Well, surface area for this one is not really that bad. I am going to first count the squares I see. Okay. I'm going to count it with my star. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I have 22. I've counted 22. Plus, now I'm going to count the ones in the bottom as well. I'm going to count the ones in the bottom that I cannot see, and you have to do it very carefully. I have 3 right here, 3 underneath this, and 1. That gives me 7, and I'm going to list it here as 7. Okay, then I have to count the back. Okay, back I have 3, 4, 5, 6. I'm going to list it here as 6. And I'm calling that back, and I have another back here. This is also my back. This one is easy to see. I have 3 plus 3 plus 3, that's 9. 6 plus 7 is 13. 13 plus 9 is 22. 22 plus 22 is 44 unit squares. Done. My volume is 16 unit cubes and surface area is 44 unit squares. I'm going to quickly check my answer, okay? 16 and 44, that sounds about right. So you have it. So we did number 1. I'm going to go ahead, and so our lecture will be a little light. I know those of you had me for 3190. It's a little repetition, but I'm going to repeat myself once again. We have a person who never had me for 3190, so it's here for that person. I'm gonna go ahead. So I'm gonna go ahead and jump out of this session. I'm gonna be back again, and I'm gonna record a little long, we're gonna do 2 more problems, okay, guys? And I'm coming back right away. So I'm trying to get out of this session. Okay, I see what's going on.